Oh, hi there. You scared the crap out of me. I'm Michael Matucci, Associate Production Coordinating Directorial Associate Managing Departmental Division Office Supervisor of the International Network Amalgamation Distributing Corporation Management Organizational Association of People Who Don't Particularly Care for Avocados. Nanotechnology generally deals with matter on the atomic and molecular scale and the creation of technology within that size. Its possible applications in our world range very wide, being applied in fields like medicine, chemistry, communication, and even consumer goods such as food and cosmetics, to name only a few. As it develops over time, nanotechnology can be very beneficial to the world in many different ways. However, there are health and environmental concerns with nanotechnology, so much so that an entire study is based on determining the possible threats of nanotechnology, called nanotoxicology. We'll touch briefly on all these subjects and more on this science project that uses the same theme song as The World of Chemistry. Now, we've all seen fictional examples of nanotechnology one time or another. Star Trek, Jason X, Stargate, Michael Crichton's 2002 best-selling novel Prey. Really? You never heard of it? Well, you know Crichton, right? Michael Crichton? Famous science fiction author? He wrote Jurassic Park. You did know it was a book first, right? Let's just move on. To give you a summary of how nanotechnology works, let's start off by giving you folks some perspective on exactly how small we're talking when we say nano. This is a carbon nanotube. It's 2 nanometers in width. Doesn't look that small, right? Wrong. Very wrong. If you thought that for even half a second, what are you doing watching this? Anyway, this is a red blood cell. It's roughly 2.5 micrometers in length. Now, I know what you're thinking. The Matrix films were just way too confusing for me. I mean, people who like it keep telling me I have to see it more than once to get it, but I honestly don't have that kind of time. Well, this has nothing to do with this presentation. Stay focused, people. Now, if you don't know how big 2.5 micrometers is to 2 nanometers, just go ahead and move that decimal 3 places to the right. That's right. A single red blood cell is about the same size as 2,500 of those carbon nanotubes you saw earlier. Now this... oh. Sorry. This is ragweed pollen. That's right, that yellow powder you find all over cars and stuff in the springtime. One of those little particles is 20,000 nanometers. And finally, this pinhead is... No, not that pinhead. That's better. Geez, they got a monkey run the slides. The head of this pin is only 1 millimeter in length, something that's much easier for you to imagine. It's, get this, 1 million nanometers. 1 million teeny tiny nanotubes could fit on the head of that pin. Get how small we're talking now? Oh. Well, I'm out of pictures, so just let's all act like we're on the same page and continue. In the world of Star Trek, machines called replicators can produce practically any physical object, from weapons to a steaming cup of Earl Grey tea, hot. Long considered to be exclusively the product of science fiction, today some people believe replicators are a very real possibility. They call it molecular manufacturing, and if it ever does become a reality, it could drastically change the world. Awesome! What about teleportation? Oh, sorry, random Star Trek nerd, but the Heisenberg uncertainty principle says it's impossible to know the exact location of an atom and the momentum of it at the same time. And unless we can measure both simultaneously, Scotty won't be beaming anybody anywhere. Well, hey, that's not very As I was saying, atoms and molecules stick together because they have complementary shapes that lock together or charges that attract. Just like with magnets, a positively charged atom will stick to a negatively charged atom. Woohoo! Nah, crap. As millions of these atoms are pieced together by nanomachines, a specific product will begin to take shape. The goal of molecular manufacturing is to manipulate atoms individually and place them in a pattern to produce a desired structure. Nanotechnology may have its biggest impact in the medical industry. Patients will drink fluids containing nanorobots programmed to attack and reconstruct the molecular structure of cancer cells and viruses, or give them really cool robot arms and stuff. There's even speculation that nanorobots could slow or reverse the aging process, and life expectancy could increase significantly. 40 could be the new 18, or 80 could be the new 30. And Japan would overpopulate so much, the islands would probably start to sink. Of course, that's why nature's given them Godzilla, or as I like to call them, giant scaly radioactive population control. But enough about the possibilities of nanotechnology. Let's see some hard evidence of its development today. Now, life elongating nanobots and T-replicating machines are all well and good, but what are some closer to home applications of nanotechnology? Well, that's a hypothetical question, of course. None of you would know. You're all morons. When it comes to the field of nanotechnology, of course. So, I'll be the one telling you. In this day and age, finding environmentally friendly and alternative forms of energy are a top priority, thanks to people like Al Gore and his magic slideshows. An important subfield of nanotechnology related to energy is nanofabrication. Nanofabrication is the process of designing and creating devices on the nanoscale. Creating devices smaller than 100 nanometers opens many doors for the development of new ways to capture, store, and transfer energy. The inherent level of control that nanofabrication could give scientists and engineers would be critical in providing the capability of solving many of the problems that the world is facing today regarding the current generation of energy technologies. Technology is already impacting the field of consumer goods as well, providing products with novel functions ranging from easy to clean to scratch resistant. Nano-optics could allow for an increase in precision of pupil repair and other types of laser eye surgery. As some of you may or may not know, laser eye surgery was responsible for forever changing the appearance of musical parody artist Weird Al Yankovic. My sources tell me he got rid of the mustache on his own, though. The use of engineered nanofibers already makes clothes water resistant and stain repellent. Go ahead and take a look at a world without nanofibers. Of course, with every new scientific discovery, there come possible risks that those darn left-wing tree-huggers won't stop picketing about. They're just rats and monkeys, people. If we want to test products on them, freeze their bodies once they die, slice them into thin sheets, and look at them under a microscope for study, that's our business. So let's take a look at the possible unintended consequences of nanotechnology. Nanotoxicology is a subspecialty of particle toxicology. It addresses the toxicology of nanoparticles, which appear to have some toxic effects that are unusual and not seen within larger particles. Nanoparticles seem to have some different properties from larger particles that are known to have pathogenic effects like asbestos or quartz. These differences seem to be as a result of their size. They have a large surface area per unit mass, and this means that in some cases they may have more pro-inflammatory effects in, ergo, the lungs, which I'm fairly certain are pretty important organs, although fish don't have them. How important could they possibly be? Anyway, in addition, some seem to be able to translocate from their site of deposition to the distant sites such as the blood and the brain, and I know for a fact fish have both of those. So there you have it. A fairly new science with some possible drawbacks, but if developed and perfected further, it could change the world for— Hey! Oh, it's you. What do you want now? I did some research, and I found proof positive that teleportation is so possible. Until the advent of quantum teleportation, through particle entanglement, the Heisenberg uncertainty principle was thought to stand as the chief barrier to developing Star Trek-type teleportation devices. But in destroying the original particle, the position and momentum need not be measured, but can be transferred through prior entanglement and classical communication channels to a distant identical particle. In your face! Well, that's just great. But have you ever had a girlfriend before? Of course I have. Outside of the internet. I thought so. Well, folks, that wraps it up for our brief look into the world of nanotechnology, and an even briefer look into teleportation and the pathetic life of some Star Trek nerd. Until next time.
We are the Borg. Lower your shields and surrender your ships. We will add your biological and technological distinctiveness to our own. Your culture will adapt to service us. Resistance is futile.
You got that right. Now enjoy the credits, folks. Seacrest out.